Hello everyone. In this video I'm going to be looking at completing the square to solve a quadratic equation. And as you can see, there are four main steps to completing the square. First is set your a value to positive 1. Now what that means is, remember we're talking about a quadratic equation, so something in the form ax squared plus bx plus c equals 0. So when we refer to a, that means the leading coefficient should be positive 1. There's my example here. My leading coefficient is currently 3, so to make it 1, the simplest thing to do is to divide everything by 3. And that'll give me x squared plus 2x plus 1/3 still equals 0. My next step is to get all the variables on one side. In other words, I have x squared and 2x on one side. I want to get my 1/3, my constant, to the other side. Now in some cases, this step may already be taken care of for you. Sometimes the constant automatically starts on one side, and that may take just a little bit of manipulation, moving terms around to where you need them. So now I have x squared plus 2x equals negative 1/3. Finally, or I should say next, my third step is probably the most critical one. This is where I add b over 2 squared to both sides. B referring to my middle term b, or my middle coefficient. Meaning whatever it is at this point, I take half of it, square that, and add to both sides. So no, this does not mean my b value is 6. To begin with, it's 6, but what we want is to use the b value when our leading coefficient is positive 1. So in this case, my b is positive 2. So when I take b over 2 squared, that gives me 2 over 2, which is 1 squared, which is 1. So this means I'm going to add 1 here and here. Now the purpose of adding this is to create on the left side a perfect square trinomial. And that's what the rest of this means. Solve. The first part of that is to factor. So I'm going to factor, in particular, x squared plus 2x plus 1. Now you can use traditional factoring methods. Think what can multiply to 1 combined to 2. Ultimately, though, this would be a quicker way of doing it. Since it's a perfect square trinomial, it's going to have quantity squared. It's going to have an x, whatever the variable is. Now that I have my variable, in this case x, quantity squared, that's always by default. So when you factor this side, you can always start with the quantity squared, then the variable. What we need is what goes in here, what number. And as I said, you could do traditional factoring methods, or you can always use this little nifty trick, which will always work. Whatever your b over 2 value is, not b over 2 squared, but b over 2. In this case, 2 over 2 is positive 1. So, we say x plus 1. And that's your factored form. So you can always fall back in that method. Whatever the b over 2 is goes in place, whether it's positive or negative. That becomes especially helpful if you happen to deal with a fraction that's b over 2. Or I should say, when you're added your b over 2 squared, happens to be a fraction. If that's ever a fraction, using this trick will make things a little bit smoother. Now over here on the right, I'm adding negative 1/3 and 1, which is the same thing as adding 3/3. So this is equal to positive 2 over 3. Now this becomes a problem where you solve by taking the square root. And let me give myself some more room here. So I have x plus 1 squared equals 2/3. So my first step is to take the square root of each side. I'm left with x plus 1 as they cancel out, plus or minus square root of 2/3. And since I want to always rationalize my denominators, this is the same thing as saying square root of 2 over square root of 3. So to rationalize, to get my square root of 3 out of the denominator, I'll multiply by the square root of 3 to the numerator and denominator. And now I'll have square root of 6 over the square root of 9, which becomes square root of 6 over 3. And remember, since 6 is inside the radical, I cannot divide it with 3. I can't make it square root of 2. It's just going to remain square root of 6 over 3. So more specifically, I have x plus 1 equals plus or minus square root of 6 over 3. Now finally, to solve for x, I must move my 1, so I'll subtract it from each side. Finally, I'm left with x equals negative 1 plus or minus square root of 6 over 3. And remember, since negative 1 is not common, or is not a like term with the square root of 6 over 3, I can leave it just as is. Now, if you wanted to really combine it into a single term, you could make this negative 3 over 3, which is equivalent to negative 1, plus or minus square root of 6 over 3. Since they have the same denominator now, you could then make it negative 3 plus or minus, let's make this a little neater, negative 3 plus or minus square root of 6 over 3 as a single term. Either one are fine answers. Oftentimes it comes down to preference and what is preferred in your particular class. So to complete the square, we follow these steps. Make a leading coefficient positive 1. Get your variables on one side. B over 2 quantity squared to both sides is added, and it's always added. And then you factor and solve. You can see the process, and it leaves us in this case with negative 1 plus or minus square root of 6 over 3 after we rationalize the denominator, which is something we always want to do.